Hello, so today we are going to do problems from weekly contest 383, this week's weekly contest. And the third problem is find the grid of region average. Yeah, this problem is very just cumbersome, so just a warning here. It requires a lot of reading, but essentially what this problem asking us to do is first, you need to, I think, understand a couple of concepts in the problem. The first concept is that the values in the cells represent what they call pixel density. So these are images, and each cell represents basically the pixel density at that specific point. And then what you have also is the concept of two cells or two pixels are called adjacent only if the sum of the difference between their x and y coordinates is equal to 1. So basically what that means is that this one and this one are adjacent, this one and this one are adjacent because the difference between the y is 0, but the difference between the x's is 1, so the sum is 1. Same thing here, similar here, the difference between the x's is 1, but between the y's is 0, and so the difference between the y's is 1, but the difference between the x's is 0, so the total is 1. Right? But if you take this one and this one, the difference between the y's is 2. The difference between the x's is 0, and so the sum is 2, which is not equal to 1. So they are not adjacent. So that's the concept here of adjacent. Now, the other concept is we call a region basically a subgrid that has these specific properties. First, it is a 3 by 3 subgrid, so it only has 3 like this, 3 by 3. Even if the matrix was like this big or bigger, then it will only be any 3 by 3 subgrid. So the first constraint, it is 3 by 3 subgrid. And then the other constraint is that the absolute difference in the intensity of the pixels between any two adjacent pixels in that specific subgrid is less than or equal to threshold. And this threshold value is given to us as a parameter, okay? So those two concepts, adjacent and threshold, are the two most important ones. And a specific cell can be part of multiple regions. So for example, here, this cell here is part of this region 1 subgrid here, but it's also part of this one, right? Same thing for 6, same thing for 12, and same thing for 7, 10, and 13. Okay, so what do we need to return? We need to return a result matrix where basically this result for each cell will contain the average intensity of the region in which that cell belongs, right? So for example, the average in this subgrid, if you take the sum and divide it by 9, because there are 9 cells, that's going to be 9. And so the value at each of these positions will need to be 9. But then for cells that are part of multiple regions, like for example 6, like these cells here, what should we do? Well, they say here if it belongs to multiple regions, then we need to take the average of the rounded down average of each of these regions. So we need to take the rounded down average of this region 1, the rounded down average of region 2, and then take the average of these two, okay? So that's and then when we take the average, then that's going to be the values for each of these common cells, okay? So that's the idea. Now let's see how we can implement it. Okay, so how do we tackle this? Well, this is going to be a purely brute force solution because if you look at the constraint, this is going to be up to 500, right? And so we can do even open to the power of, let's say, squared. We can definitely do that because that would be 5 multiplied by 10 to the power of 4. We can even maybe do 10 to the n by m to the power of 3 potentially as well. So yeah, we can do just a brute force solution. Now for the brute force solution, 2 things we need to care about. One is how do we determine that two are adjacent, right? And then the other one, how do we do just the region? Well, that's going to be pretty simple. So I'll just not do an overview, like a whiteboard overview. I'll just look at the code directly because it's purely brute force. So the first thing we need to do, of course, is just look at the each potential start of a subgrid, right? So for example, here, the starts of a subgrid, the only possible candidates here are this one. By the start, I mean it's going to be the top left, and this one, right? Because if you take a look here, if you take this one, for example, you can't get a 3 by 3 because it's going to be out of bounds. So the only possible starts are going to be until row minus 2, because this means basically you will stop at the number of rows minus 3, so that you can have rows minus 3, rows minus 2, and then rows minus 1 as the 3 positions. You need 3 by 3, right? Similar thing for columns. So only up to these that we can actually have a potential top left corner for our 3 by 3 grid. And then from there, it should be just brute force. So what do? We check if it's a valid region using the definitions of a valid region here, where basically it's 3 by 3, of course, but also the absolute difference in intensity between the adjacent cells is less than or equal to threshold value. For example, here 3. So we are going to check that. We can write the function later. But also, just to not do a lot of work, we can calculate the actual average while we're checking if it's valid. So the actual average is going to be just the sum of the values of the subgrid divided by 9, because there are 9 elements. So we can just take the sum and then divide by 9 and then return that. In Python, you can return 2 parameters. If you have another language, you can return just like a tuple or a data or some sort of instance of a class. Now, if it's valid, so if it's valid, then we need to fill our result grid. Okay, so how do we fill up our result grid? Now, this is where it becomes interesting, because we have the problem that we may have multiple regions for the same cell. So for example, cell 9 here has 2 regions. So its average is its value for result is going to be the average of this one plus the average of this one divided by 2. And so just to do that, first what we are going to do, if it already had, just pay attention to this line here. If it already had a result in it, right, then we'll just keep computing the average and compute the count. So what I'm doing here is the result first for me is going to have 2 things. It's going to have the average so far, right, and then the number of regions. Why are we doing this? Because at the end, what we want to do is take the sum of the averages. So this is going to be the sum of the averages of all regions that this cell is part of, and then divided by the number of regions it's part of. And so we just add the average of this region, right, which is this one here, this value. We add it to whatever we had previously, which is at position 0, the sum of the averages so far. And then we take the count of the regions so far, and then we add 1 for this specific region. So this is if there was another region before. If there wasn't, then we just put the average for this region and then put 1, because so far it's only 1 region, and we check. Here we just check if it doesn't have any. We could also here just check if it's not updated. So we could do 0, 0, right? But that's the same as checking if it's part of any region at all, okay? So that's just the core here. Now, 2 things we will check. How do we check that a subgrid is valid? But first, also, how do we calculate the result? So here, once we do this, what we will have at the end is the sum of the averages so far for all of the regions, and then the number of regions. So we just need to divide this by the count of regions to get the average for that specific cell. And that's what we are doing here, right? We just take the sum of the averages so far and then divided it by the count of regions. However, there's one case, which is What if it wasn't part of any regions? So the value is still 0, 0. Well, for those cases, we need to just put the sum of the value of that specific cell. Sorry, we need to just put the initial density or the initial intensity for that specific cell. And so that's what I'm doing here, okay? Okay, so now the last part, which is going to be just checking if this condition for a region is valid or not, which primarily is going to be checking if the absolute difference between any adjacent pixels is less than or equal to threshold. So here first, we have the starting point of our grid, of our subgrid or our region, and since it's 3 by 3, we just, for each position, for each cell in that region, to get it, we just go through all the possible rows, which is going to be just from the starting row to the row plus 2, which this will do, and this is going to be for the column from the starting column to the column plus 2, so that we can have the starting column plus 1 plus 2. And then we keep track of the sum as we go. This is just so that we can return the average that we will return here. Not a big deal. But this is where it's interesting, this part here. So this part, what it does, instead of going through every 2 cell and checking if they are adjacent, we can just use a construction, since we know the only 2 cells are only adjacent if the difference between their coordinates is 1. And so let's just, going from this coordinate, let's pick only adjacent cells. What are adjacent cells? It's the one that is only the x coordinate is plus 1, so that the difference ends up equal to 1, or only the j coordinate is plus 1, so that this would be 0 and this would be 1. Okay, and we just go through the 2 possibilities. Now we need to make sure that we are still within the bounds in case we are at the last row in the last column, so that's just what we are doing here. But once that's the case, we want to check if it's now we constructed I2 and J2 that is adjacent to I1 and J1. So we need to check if we find any occurrence where it's bigger than threshold, then that means this is not a region. But if all of them are small or equal to threshold, then we can return true. And so here we check if the difference between the intensity of the pixels is bigger than threshold, then it's not a region, which is this exact condition. And so we return false in that case. But if we checked all of them, all the positions and all of their adjacent, and all of them were below or equal to threshold, then we can return true, because that means it's a region. Okay, and then we return the average here. We just keep track of the sum as we go through each cell. And then we divide it by 9 because we have 9 cells, and that's pretty much it, right? And so pure brute force, we just go through every possible left top corner of subgrid, check if it's a valid region. If it is a valid region, we keep track of it and of the number of regions that cell is part of, and then at the end we just get the actual average value, and then we just return it. Yeah, so that's pretty much it. This problem is pure brute force, but you need to be careful with your implementation. And that's pretty much it. Thanks for watching, and see you on the next one. Bye.